Okay, so this is another homework question from thermophysics that I'm going to go over. I'm probably just going to spam upload a couple because I have a quiz tomorrow, so it's worth, I guess, going over. So it says the molar heat capacity of gold is 25.4 joules per mole per Kelvin. Its density is 19.3 times 10 to the third kilograms per meter cubed. Calculate the specific heat capacity of gold and the heat capacity per unit volume. What is the heat capacity of 4 times 10 to the 6 kilograms of gold? It's roughly the holding of Fort Knox. So the equation we're going to be working with is big C, let's draw that a little nicer, is equal to little c times, I'm going to write this as big M, little m, molar mass. So just so we know what all this is the molar heat capacity. This case, it's our heat capacity. Or in this case, it's the molar heat capacity. It's also just your heat capacity. This is your molar mass. So that's why we're using M here, because this is the molar mass. What's the molar mass for gold, by the way, is 0.197 kilograms. And then this is our specific heat capacity. Okay? So little c is equal to big C, that's supposed to be a big C, divided by your molar mass. So if you plug those values in, that's 25.4 joules per mole per Kelvin divided by the molar mass of 0.197 kilograms. If you plug that in the calculator, you should get about 129 joules per mole per Kelvin per kilogram. So that is your specific heat capacity. Now B wants to know, I'll call it part B. It says to also calculate the heat capacity per unit volume. So the heat capacity per unit volume, that is simply your, what we just found, C, your specific heat capacity, times the density. So 129 joules per mole per Kelvin per kilogram times the density, which they already gave us as being 19.3 times 10 to the third kilograms per meter cubed. So that ends up being 2.5 times 10 to the 6 mole per Kelvin per meter cubed, because this kilogram and this kilogram will drop. And then C just wants us to find the heat capacity of 4 times 10 to the 6 kilograms. Well, again, we're going to use our same equation as we did before, so this, I guess we could say, is C. Is big C, your heat capacity, is your specific heat capacity times the mass. Now, in this case, we're not going to use molar mass because we're not interested in the... we do have the molar heat capacity, but the mass that we're interested in is this amount. So instead of doing molar mass, we're simply going to use that mass. And again, in part A, we calculated the specific heat. So big C is 129 joules per kilogram per Kelvin times the mass, which they gave us as 4 times 10 to the 6 kilograms. You see the kilograms will drop, and you should get 5.16 times 10 to the 8th. Again, the kilograms drop, so it's just Kelvin or joules per Kelvin. Okay. So this is going to be big C equals little c times m. That's going to be the main equation we're working with here for this question. And most of the problems revolve around that. And in part A, we have the molar heat capacity, so that's what this big C is. And then if we're dealing with the molar heat capacity, we want the molar mass. And then if we want the heat capacity per unit volume, all we need to do is take your heat capacity and multiply it by the density, which they gave us. And then C, again, if we want the heat capacity of that much mass, now it's no longer molar mass. So this M here is no longer molar mass, it's just that mass. So hopefully that kind of makes sense. And I will probably push out some more videos on these type of questions here soon.